Welcome to the Project Management Prepcast, the key to PMP exam success. Here's your instructor, Cornelius Fichtner.
Hello and welcome back to the Project Management Prepcast. I'm your instructor, Cornelius Fichtner. The focus of this lesson is a number of advanced theories and concepts from project cost management that are not necessarily discussed in the PMBOK guide but still needed for the PMP exam. In this lesson we describe sunk cost and explain opportunity cost. We explain what value analysis is all about. We define other concepts which aid in financial investment decisions and are particularly helpful in the project selection process. These concepts include the internal rate of return, the return on investment, benefit cost ratio, and payback period. We introduce the time value of money concept and explain the difference between present value and net present value. We also then clarify the two ways of representing negative numbers. Does this sound like a lot to cover? The good news is that you don't really have to be able to calculate many of the formulas behind these concepts. Instead, you have to understand the concepts themselves and make appropriate decisions on your projects based on your understanding. Let us begin with sunk cost. According to Wikipedia, sunk cost is a retrospective past cost that has already been incurred and cannot be recovered. I highlighted a few words here. First, when talking about sunk cost, it is in the past or after the fact. Therefore, it is not a planned cost in the future. No, you have already engaged in a course of action where costs have been incurred. As such, you cannot simply undo your actions to recover these costs. Let's dive straight into a couple of examples so that the concept really sinks in. And yes, that pun was fully intended. For our first example, let's go back in time to around the 1500s when merchants engaged in the lucrative sea trade. Sea merchant fortunes depended on their ability to transport goods to and from the New World by ship. Sea trading, however, is a risky business, and even more so back then. Indeed, if a ship were lost at sea, the implications were likely loss of life, but in addition to that, the precious cargo and the ship itself would also be lost. Alas, from a sea trader's monetary perspective, the sunken cargo and ship, they represent sunk cost. There was not much deep-sea treasure recoveries available back then. If the ship and the cargo sank out in the middle of the sea, there was no way of getting it back. The cargo ship and costs associated with it are unrecoverable. But now let's come back to our own time and talk about my mountain bike. When I bought the mountain bike, I invested about $1,100 into it. Since then, I've needed to take it to the shop several times to get it fixed. Overall, I guess I spent about $500 in various repairs on getting the bike fixed on many different occasions. Now, I once again have a flat tire. Actually, it's both the front and the back wheels that have flat tires, and I have to spend quite a bit of money repairing this bike because frankly, I'm not all that great when it comes to being handy around the house or around the bike. It's going to cost me at least another $80, but once it's fixed, I will once again have a working bike. In general, I should look at only my current needs and my future benefits. When faced with the decision on the pending repair, I should not worry about all the money that I've already spent in the past on this bicycle in order to make the decision, should I or should I not have the bike fixed. So in the case of my bike, it makes sense for me to spend the money to repair it, but that may not always be the case. Have you heard the expression, don't throw good money after bad? It may be the same thing with the sunk cost on your project. So if you have already spent $500,000, say, on project A, and you now need to invest another $200,000 in order to get back a profit of about $400,000, 100,000. Then you have project B, where you could invest 100,000 to also get a profit of 400,000. If you had limited resources and you had to choose between projects A or B, should you still move forward with project A? Remember, the sunk cost is gone. That $500,000 investment is like that sunk ship on the bottom of the ocean. As a project manager or project sponsor, you need to make the rational choice. Don't throw good money after the bad one in project A. Based on these numbers, project B sounds like the better option and the better investment. So another takeaway from this discussion of sunk cost is don't look back. Look forward. Perhaps to those in finance and accounting, this is easier to just stick to the numbers. But for many people, including us project managers, that's easier said than done. We have attachments to the past. Perhaps it's a false optimism that things will improve, or perhaps we don't want to admit that we took a wrong turn in the past. We need to be aware that psychologically there is an attachment, and this way of thinking is fairly common. However, in our projects, we need to try to be objective and evaluate opportunities with a forward-looking attitude and not a backward-looking attitude. Next, we have another kind of cost to discuss, and that is opportunity cost. According to the Merriam-Webster Online Dictionary, an opportunity cost is the added cost of using resources, that is the difference between the actual value resulting from such use and that of an alternative. Well, we know that opportunity cost is a type of cost, but what is it? Basically, every decision you make in your project will have some kind of a cost implication. On the project, you have limited resources. You have both time and cost considerations. So that is what we are talking about here. That is the difference in value between choosing one path versus an alternative. So, for example, you own an acre of land and you had to choose between planting rice or planting corn this season. If you choose to plant rice, then the value of the corn harvest is your opportunity cost. So you see that the opportunity cost looks at what you could have done, but you opted not to do. So it represents a missed opportunity. It is what you could have earned, but you didn't because you chose a different path. For example, you could have bought that old chair at the flea market last Sunday for $5. Instead, you decided to eat and buy a hamburger. The chair then turned out to be a Chippendale worth $10,000. So you have a missed opportunity, and your opportunity cost here is $10,000. It's 100% of what you did not earn. Note that the opportunity cost is always 100% of the opportunity that you did not select. So in our chair example, the opportunity cost, the chair was worth $10,000. That is your opportunity cost, and not $10,000 minus the $5 that you would have paid for the chair. No, it's always 100% of the option that you did not select. And also, when you are faced with many options, the opportunity cost considers only the value of the next best alternative, not the sum of all the other options. Let's go back to our field example, because you weren't really just limited to rice and corn as the crop to plant on your acre of land. You could have planted wheat or peas or potatoes or any other crop, really. But when you consider your opportunity cost, you do not add up the value of all the types of crops that you could have planted and could have sold but didn't choose to. Wouldn't make any sense. You only have 1 acre. The choices are assumed to be mutually exclusive. So you only look at the next best alternative as your opportunity cost, which in our example was corn. So you consider only the value of the corn harvest, the missed corn harvest, as your opportunity cost because you chose to plant rice. Another relatively easy concept to understand is the value analysis. The idea behind the value analysis is to first examine all the requirements, features and functions of your project's final product. The next step is then to assign a value to each of these requirements, features or functions. In your next step, you are now going to try and reduce the cost of each of these, but without reducing your scope. So you will still fulfill all the requirements and keep all the features and functions, but you try to produce them less expensively. You attempt, in other words, to create a cost reduction without a scope reduction. That's really what value analysis is all about. Now let us turn to the concept of the internal rate of return, the IRR. First of all, calculating the IRR can be rather complex. The good news is you don't have to be able to do that for the PMP exam. And rather than providing you with a definition up front here, let us explain this through an example in an investment question. Let's assume that you have some money and you can invest this money either in bonds from company A that have a yield of 7%, or you can invest this money into company B, where you will get a yield of 5%. Now, let's assume that all else is equal. And what I mean by this is, for this example, assume that the risk is the same and that you only have these two options. Which one would you choose? Of course, you would go for the one that gives you the higher yield. You would take company A because they're paying out a 7% interest, and it's exactly the same with the internal rate of return in investing in different projects. For example, if instead of company A and B you had to choose between project A and B, you would of course choose the project with the higher return or internal rate of return. Now we are ready to look at the definition. The internal rate of return, IRR, is a capital budgeting method used by firms to decide whether they should make long-term investments. The IRR is the return rate which can be earned on the invested capital. That is to say, the yield that you get from that investment. Since it's relatively easy for anyone to go to a bank and deposit the money in an interest-bearing financial instrument like savings account or a certificate of deposit, a CD or a time deposit, therefore a project is a good investment proposition if the IRR is greater than the rate of interest that you could be earning if you look at the prevailing interest rate for the period of time frame of your investment. Just remember, all else being equal, the investment with the bigger IRR is the better investment. There are alternative investment choices out there that you are not limited to investing your money in the bank. These different alternatives have different rates of return and different risks associated to them. So amongst your alternatives, when looking purely in terms of the IRR, you should always choose the investment with the highest IRR. Realistically, you would also need to consider risk and weigh in risk versus return in making your investment choices. But don't worry, like I said about the formulas for this, because you don't need to know the formula of the IRR for the exam. You just have to know that the project with the higher IRR is the better project, and that's the one we should go for. For the next concept, we have what is known as the benefit-cost analysis, or also the cost-benefit analysis. On our slide here, we will use the former term, the benefit-cost analysis, which is really the process of looking at the quantitative and qualitative costs and benefits of a project. The goal of benefit-cost analysis is to do the following. First, you conduct a benefit-cost analysis in order to determine if it is a sound investment or decision. In other words, if you were going to do a business case, this would justify the project and support its feasibility. Second, you want to provide a basis for comparing projects. So if you have a list of candidate projects to choose from, then you would want to look more closely to see the pros and the cons for each of your projects. And one of the key quantitative methods in performing a benefit-cost analysis is using the benefit-cost ratio. Let's now more closely look at this very important ratio. We already learned that if all else is equal, if you have two projects, you select the one with the bigger IRR. And this rule to select the project with the bigger number is also valid for the next term here, the benefit-cost ratio, also known as the BCR. But what does the benefit-cost ratio actually tell us? As the name implies, the BCR calculates a ratio between the benefit and the cost of a project. The bigger the difference between the benefit and the cost is, the bigger the ratio will get. For instance, a ratio of 5.1 indicates that this project is preferable over a project that only has a ratio of 3.5. But now let's turn this around and say, all right, I have a BCR of 5.1. What does that mean? Well, it means that your benefits are 5.1 times greater than your cost. And instead of benefit, you could also say payback. So the payback is 5.1 times greater than your cost. And this takes us straight to the next topic, the payback period. You've probably heard this term before. To put it in technical terms, payback period is the length of time required to recover the cost of an investment. Let's take an example where a $1,000 investment returns $500 per year. This would have a 2-year payback period. It is intuitively the measure that describes how long something takes just to pay for itself. Shorter payback periods are obviously preferable to longer payback periods. I know you may be getting tired of hearing it, but I have to say, as long as everything else, risks and all the other factors are equal, then the sooner you have your original investment back, the sooner you can opt to invest into something else and get a return. And the sooner your original investment can start earning profit for you. So for the exam, what you need to remember is that when you are comparing the two payback periods of equal projects, then the payback period of 6 months is better than a payback period of 12 months. But you can easily see that you really couldn't evaluate a project on payback period alone. Payback period is focused on when you can recoup your original investment. It doesn't care about anything that happens after that. For example, it doesn't consider profitability. This is where a metric like the return on investment, ROI, becomes useful. It is used for the evaluation of the efficiency or performance of the investment. In other words, it's a metric gauging profitability. Looking at the formula, you can see that the numerator is effectively profit. This is the gain from the investment less the cost of the investment. You could call it the benefit or return on the investment. The denominator is the cost of the investment. This can be expressed as a ratio or as a percentage. This is yet another ratio where, if all things are equal, the bigger number is the better number because you get more bang for your buck. To visualize this in the photo, it means that the larger the ROI, the more gold would be spilling out for each coin that you inserted as compared to an investment with a smaller ROI. In other words, your money is creating more value for you. ROI is just one of many measures useful in comparing different investments such as projects. It is a very popular ratio as it is quite flexible and easy to understand conceptually. Let's go straight to an example and pretend that you are the president of the Parent-Teacher Association for your school. And this year you decide on an experiment. You give $1,000 as seed money to 2 different fundraising projects so that you can figure out which one has the better ROI for next year. So Project Alpha. Project Alpha receives those $1,000 in seed money, which they spend on shirts, creating a design, printing the design onto the shirts, and they spent the year selling the shirts that they had, and they sold $3,000 worth of those t-shirts. So the ROI is 3,000 minus 1,000 divided by 1,000, which means you have 200% for your ROI. Project Beta is a group of parents who decided to run a raffle. They also received $1,000, which they spent on prizes and printing raffle tickets and posters. They sold as many tickets as they could, and they had ticket sales of a total of $5,000. So their ROI is 5,000 minus 1,000 divided by 1,000, which gives us a 400% ROI. So when comparing the two projects purely on the basis of return on investment, Project Alpha, the t-shirt project, earned $2 from every dollar that were invested, whereas Project Beta, the raffle project, here the PTA earned almost twice that, $4 from every dollar that was invested. So in other words, all else being equal, next year the PTA should choose to do a raffle. Which then brings us to the notion of the time value of money. No, I don't mean time is money, which is more about how we value time because it is a limited resource. This is a bit different. Fundamentally, time value of money means that a certain amount of money in the present, today, has a different value than receiving the same amount of money in the future. Let me explain. If I were to give you $100 now versus $100 a year from now, which one would you pick? Consider that if you had the money today, you could invest that money. We just talked about interest on a previous slide. Your $100 today would be worth more a year from now if you invested it in your bank account. There is also inflation to consider, however, so you might have more buying power today. In other words, you can get more with the $100 today than you would with $100 a year from now when inflation has gone up. And clearly, given this choice, you should select to get that $100 now instead of waiting a year to get the same $100. Let's jump into the details and see how we calculate present value and future value, beginning with the present value here. So if I gave you $100 in the future, how much money would I have to invest today so that this $100 exists in the future? If you think about it, you had to discount the $100 future by the interest rate. Let's take a look at the formula here. So the $100 in the future has to be the present value times 1.05. And if we calculate this out, the present value of $100 divided by 1.05 gives you $95.23. In other words, the present value of $100 that I give you a year from now is $95.23 today. If I take $95.23 today and I put them into a bank account where I get 5% of interest in a year's time, this money will have grown to $100. So the present value of $100 in a year from today at 5% interest is $95.23. And of course, now we can go ahead and we can turn this around and look at the future value and say, well, if I give you $100 today at a 5% discount, what value does that $100 today have in a year from now? Because your money today will change according to the rate of interest. It'll grow. And of course, it looks like this. The future value equals 100 times the 1.05% right there, which will end up with $105. In other words, $100 today that I give to you and you invested in a bank account where you earn 5% over a year will be worth $105 a year from now. Present value and future value are those areas that you may have to be able to calculate on the PMP exam. The previous example was very simple. We only considered 1 year in our time frame. When we look at this now, we introduce a more general formula for our present value. Here it is. Present value equals future value divided by 1 plus r to the power of n. This is the formula in order to calculate the present value. So you take the future value and you divide this by the compounding interest. This really is what the item at the end is showing us here. You can use the same formula in our previous present value example to get the same result. You use n equals 1 as your time period is only 1 year in our original example of me giving you $100. And as you can see in the abbreviations there, we have PV, which is present value. And please don't confuse this with the planned value, which is part of earned value management. PV, present value, and PV, planned value, two totally different concepts. FV is obviously the future value. R is the rate of interest in percent. So this would be your 5%. And N is the time in years. So you take your PV or present value and then that equals your future value divided by 1 plus the rate of interest to the power of the n, which is the time investment in years. Here is another example of our present value calculation. Assume that we have a future value of 1 million. The annual interest rate is 12%, and n, which is the time that it would be invested, is 3 years. So that means that our present value, PV, is 1, that is 1 million, of course, divided by the 12% interest raised to the power of 3, and the result of this calculation would be that it's $711,780.25 US. So if we invested that amount of money, the $711,000 US at 12% interest for 3 years, we would end up with $1 million US in 3 years. That is the result. The amount of money you need to invest today, planned value, for n years at the R% annual interest rate in order to end up with our target sum, which is the future value. Now let's take the time and see how this money actually grows from $711,780.25 as our initial investment in year 1 all the way to the 1 million. So we see in the first year we are able to earn the 12% interest, roughly $85,000. And the balance has now gone up by those roughly $85,000. We're already having $797 in our bank account. In year 2, once again, we receive 12% interest. But of course, the 12% interest are now on the balance of $797,000. So we get $10,000 more in interest already. So we already received $95,000 US in interest. Now we have $892,000 US as our balance. And then in year 3, we get 12% interest on the 892, which gives us roughly 107,000. We will end up with $1 million US at the end of year 3 if we invest $711,780.25 in year 0, and we get 12% interest every year. An analogy that I want to make here in this lesson is that future value and present value are like apples and oranges. What do I mean by that? Well, basically a present value and a future value, as they are in different time frames, cannot be practically compared, added, or subtracted. So what do? Well, you don't make fruit salad. No, you simply have to ensure that all values have the same time period before comparing adding or subtracting. Let me give you an example. Let's say you had to find the value of two projects combined. Project A had a future value of 1 million 3 years from now, whereas Project B had a future value of 1 million 5 years from now. You might be inclined to just add them up together and get 2 million, but you can't do that. Remember, until the values are in the same time frame, you can't add, subtract, or compare them. So first you have to select a time frame and convert them from there. So in other words, you either have to say, okay, how much is Project A worth in 5 years? And then you can compare Project A and B based on the 5-year time frame, or you say, okay, how much is Project B worth in 3 years? And then you can compare A and B on the 3-year time frame. And this takes us to the next topic, which is net present value, which is of course very much related to the present value. The net present value is a standard method for financial evaluation of long-term projects. This is used for capital budgeting and widely throughout economics. Net present value measures the excess or shortfall of cash flows in present value terms once financing charges are met. And this here is the formula to calculate net present value. It's the present value of cash inflows minus the present value of your cash outflows. But there is no need to remember the formula because you won't actually have to do any NPV calculations on the PMP exam. But you need to know this. If the NPV is greater than 0, then the investment is profitable and the project should be accepted. If the NPV is smaller than 0, then the investment is at a loss and the project should be rejected. And if the NPV equals 0, then the investment amount is neutral, and you'll need to look to other indicators to see if you should do the project or shouldn't. And of course, if you compare the NPV of two projects, again, all else being equal, then the project with the greater NPV is the better project. To finish this off, I'd like to discuss negative numbers with you. Yes, numbers that are below 0, because there are two formats in which negative numbers could be shown to you on the PMP exam. And the first format is simply the number 1, 2, 3 there with a minus sign in front, which means this is minus 123. Or it could be shown to you in this format here, 1, 2, 3 in parentheses, which also means minus 123. This second one here in parentheses is a standard that comes from accounting practices in the United States of America. So if you see a number with parentheses around it, it also means minus. And sort of as a review, here are some concepts that you must be familiar with in regards to cost management. Some of these we looked at in this lesson and some of them we discussed in other lessons. So within the area of project cost management, you should be familiar with the following terms, their associated concepts and formulas in order to prepare to take your exam. In cost estimating, for instance, you need to know the difference between analogous estimating, bottom-up estimating, parametric estimating, and computerized estimating tools. You also have to be familiar with earned value techniques and all its formulas. You have to know the formulas, you have to be able to apply the formulas, and you have to be able to interpret any results from earned value calculations. You should be familiar with the terms variable cost, fixed cost, direct cost, and indirect cost, and you should be able to explain what project life cycle costing means. And of course, you must understand the basics of present value, net present value, the internal rate of return, the payback period, the benefit-cost ratio, and also the cost-benefit ratio, value analysis, as well as sunk cost and opportunity cost. And to practice all of this, I have two relatively simple PMP exam sample questions for you. You should be able to figure these two out quite easily. So, what best describes sunk cost? Is it A, unrecoverable cost, B, hidden cost, C, depreciated cost, or is it D, discounted cost? The correct answer is, of course, A. Sunk cost is unrecoverable cost. Remember the example of the ship and cargo that was lost at sea when we talked about sunk costs. Those were unrecoverable cost. A sunk cost is a past cost which has already been incurred and cannot be reversed. And our second exam sample question is this here. Which project would you recommend based on the following information? You have 4 projects with 4 different net present values. Which one do you pick? This one should have been extremely easy for you because all else being equal, you should select always the project with the biggest net present value, and that is C, where we have 2.5 million in net present value. All the others are smaller numbers. Remember, when it comes to net present value and internal rate of return, the bigger number is the bigger number. Same with the return on investment. And this concludes our look at additional project cost management formulas and concepts. So it's time for Justine to say,
soon, soon.
And I say, until next time.